Today we are going to learn about the new kind of data structure called linked list. Linked list is like a basic data structure like an array, and it can be used to implement other data structures, that is stack, use, etc. So why do we use linked list? Arrays have some inbuilt difficulties to work with, like the size of an array is fixed. It cannot be changed in runtime. So always there is a chance of wastage of space if you are using array data to the minimum, and you cannot use more data if the array size is smaller. And also insertion and deletion in arrays are expensive. The reason is that if you are trying to insert in a particular position, you have to shift the data values to the right by one position to make a place for the inserted data value. Similarly, in the deletion case, it is very expensive, as when you are deleting an element, you have to shift elements to the left to cover the place of that element. So, like arrays, linked list is a linear data structure, but unlike arrays, they are not stored in contiguous location. The elements are linked using pointers. So, what are the advantages? Dynamic size. So, you can change the size of a linked list in the runtime. And there is ease of insertion and deletion in the linked list. So it basically uses heap memory. So typically linked lists are shown as figure given below. That is, in a chain A, B, C, D and D points to null. However, in reality, within a computing system, it is almost like a table. So supposedly there are 4 addresses to store the 4 values. We store in 8001 A. But another part of A, that data structure will consist the address of the next pointer, next value, next node. So that is called, let us say, is stored in 53. So we put 53 in here, B is stored in 53. So in 53, come to 53, then B is stored in here. So we want to store something in the next node C. So we store in 8009. So basically, these are all done dynamically, so we do not care about the addresses. So we go to 8009, we see C, and from C we jump to 9974D. So it is basically null. We see that the addresses are not contiguous in any way. So in C, linked lists are implemented as self-referential structures. So basically struct, node, int, data, struct, node, kernel. So you are declaring a node, structure node, which will contain data and it will contain also a pointer which will point to itself. So it is denoted as star next. So in here, in main function, we have declared 3 arrays, that is, 3 nodes, head, second and third, which are of type start node. They are all pointers. And we are now allocating addresses to each pointer using malloc or malloc. We are allocating memory to each head. So head is now allocated memory of type start node. So each pointer head is now this one. This blue is represented by head, second is represented by the orange, third is represented by the yellow. Since memory is allocated, address is allocated, now memory and address, so we see we will now insert data. Now head, since it is a pointer, we do not use dot operator, we use the pointer operator, that is arrow data, head arrow data is equal to 1. So value 1 is inserted in here. And head next we put it in second value. So similarly, as we do this, the second value also is input data like this way. Second data is equal to 2 and second next equal to third. And third data equal to 3, so third next we put as null. I think you have understood how a linked list looks like. So this is your assignment. You have to implement the linked list as shown in C programming language. Try to display the numbers on the desktop. Use the hint node equal to node2.next, node that is arrow next, to jump node to node. Thank you. Today we are going to learn about linked list operations. In the earlier class, we have learned that how to use pointers to create a linked list. Now we will learn that when the linked list is created, we want to modify the linked list by inserting, updating, and deleting information from it. So the three basic operations in a linked list are basically insert, update, and delete. So we will first look at the insert operation. In the insert operation, you see that there are in here the 4 nodes are already present. So A, B, C, D, and we want to insert E node between B and C. So it will be A, B, E, C, D. But the thing is that to insert this node, we have to change the pointer addresses in each of the nodes. So supposedly the node that we have to change is basically B and E. So B should point to E and E should point to C. So the B's earlier pointer location, which was at C, should change to E and E should point to C. So in here we keep a pointer, 2 pointers. One is the pointer to the particular node and the temporary pointer TMP, which keeps tab on the earlier node into consideration. So we'll look into the operation right now. So in the left hand side is the code and the right hand side is the operation. So we have created a code E where we have inserted data. That new data is basically E and it points to basically null. E now points to null if you look at this information. Now we know that new node dot next is basically, so B which was pointing to C, now E also should point to C. That is, we have to change E's next pointer information. So temporary pointer which points to B, this pointer is used to change the pointer of E. So we write here new node not next equal to temp next. That means E's pointer now points to the same node as of B. Now we change B's node for B's next pointer to E node by writing this statement, that is temp next equal to new node. So temp will be found as previous node in the left hand side code. So in this way we insert E between B and C. I hope you have understood. The next operation is about the update operation. In here, supposedly we want to change all the numbers that are equal to 10 is equal to 5 right at this table. So in this case, we start from the head node and till we do not reach the null, we go pointer by pointer from head. So head 5 will point to now 10. Now as soon as it finds the temp data as 10, it will change it to new data. That is, it was old is 10, it will change to new, that is 10 is changed to 5. So it's a very simple code, it's updating, it doesn't need any updation of that is next pointer, just updation of the data pointer. So it's very simple. I hope you understood this update operation. So in here what happens? While current is basically points to head node first, then current next not equal to null, that means still current is not equal to null, the while loop will run till from current to current next, that is current next, that is current equal to current next will at first will pointing to 5, then will point to 10, that will point to 15, that will point to 20, and current next equal to null, it will stop. But when it finds any old data, that is 10, it will change the data to 5. So as soon as it changes the finds the 10 old data, it changes to 5. You look at the code and try to implement at your home. The next is very important, that is deleting a node. Supposedly there are 4 data, 5, 10, 15 and 20. We have to delete 15, the node that contains the data 15. In the same case as the insertion case, we have to take a previous pointer that points to the previous node before 15. So previous 15 will now point to the node that 15 points now. 15 points to now 20. So 10 should point to 20 and we should release 15 after that. So there is a function called free node which releases the memory held by 15. We will see in the next slide. So in here we see that 5, 10, 15, 20, same as previous, we kept this previous as the previous node and temp equal to temp next. So if temp is not equal to null, it will return. Otherwise, what it will do, previous next, that means 10 was the previous next, it will point to what? That is the temp next. Temp next is basically what? Temp was the 15. So 15 next pointer is now pointed to by 10 also. So temp is the current data, that is 15. So temp next is 20. So previous next data is point which was pointing to 15. It will point to 15th temp. That is, if the address content was here some 9000 and the address content was some 8. So 8 will be replaced by 9000. So now 10 will now point to 20, and finally we'll free temp to release the 15 node. So 15 now gets deleted. So this is how insertion, updation and deletion is done. I hope you have understood these three operations. So you have to implement insert, update and delete in a linked list. That is your assignment. Today we are going to learn about linked list applications. In our earlier classes, we have used linked list for insertion, updation and deletion. Today we are going to use linked list to implement a stack and queue, and also we want to do two different versions of linked list. You will see that is, one is called the W linked list and the circular linked list. So at first we will implement a stack using linked list. So a stack is a basic data structure that can be logical thought of a linear structure represented by a real physical stack or pile. A structure where insertion and deletion of items takes place at one end, called top of the stack, is also called last in, first out. So you already know the definition of stack is just like a pile of disks. So the first element, the last element which goes into the stack is the first element to get out. So the insertion and deletion happens at one end only. So therefore you have to push at one end and you can get a pop from one end only. So we will implement stack using a link. So you see that we have already implemented a stack using a linked list. You see the last node that is inserted is 9. That is this one. This is the 9, and 9 represents the top of the stack. The other elements that are inserted in this way already the stack are 4 and 7. So you see there are different addresses also. So address will define the next address also. So the next address is given in pink column, that is 7000 for the last element, null there 40, last element that is 7, and 4500 for the second element address, and 6040 for the first element address. The first element address is also pointed by the top and the head. There are two pointers to point the top of the stack. So this is this one. So we are going to insert into a stack first. So we will take a temp node, that is which is the type of this node, and we will insert data, that is 2. So we are inserting 2. So its data value is 2, and we will point its link to the top of the element. So temp will point, temp has an address. So temp address is 5000, and when it says that temp link is the top, so basically temp's next address becomes the address of the top element. Currently it is held by 9. So it's 4500. So its address is basically 6040. This 6040 gets copied into temp's address stack, and now we put top, which was earlier pointing to 4500. Now it points to this temp using this one. That is, it is 6040. So please do not get confused. So these variables address is 5000, the temp variable, the others are 9, 4, 7, 7, and these are the address values contains the next address, next node address. So let us pop two items. We are going to pop 2 and 9. So in popping is what happens. So in this case, top element is used. Top is basically top points to top pointing link. That is next pointer. Link in here is the next pointer. We have used next pointer in our earlier class, but this is in here denoted by link. So one is top link is done. Top link we make it equal to null. So top's current link is basically the next pointer. Top link is made. So temp link becomes null. So the element which was earlier equal to temp. Let us say that temp is a basically pointer which points to the top of the element. So we have to delete first 2. So temp pointed to 2. Now top position changes means it points to the next position address. So 2 now points to 9. and now temp link equal to null. So basically 2 points to now null and we free 2. Then that happens to the 9 also. So temp now holds the 9th position. Now top position changes to after to the next, that is top equal to top, pointing link, that is the next position. Now it holds 4. Now temp link is basically null, that is 9th link is basically null and we free 9. So this way the pop operation takes place in the linked list, so that is the stack implemented using linked. Now we are going to see another data structure, that is queue. So queue is an abstract data structure somewhat similar to stack. Unlike stack, a queue is open to both ends. So you have already know about queues. So it is just like a queue that is we see every day in our life for a bus, for a cinema hall ticket. So the front end, so the queue increases from one side and it dilutes from another side. So that's why it is called first in, first out methodology. And you see this one is the basic diagram of the queue. Now how to implement using linked list. So initially we put front equal to null, rear equal to null, and when we are trying insert equal to 10. So basically what is that? We have created a new node who's basically, we have created a new node called this whose value is 10, and new node's next value is basically null. So what it happens now, if it is empty, so front and rear both points to 10. So that is how it happens. Now both front and rear points to 10. Let us insert another element. We are going to insert 20. Now the value it happens is that now the 20 has to be inserted from rear end only. So in that case, front remains same, front points to 10 only, and we change the rear equal to basically we created this node that is 20, and rear next points to the new node. Rear next points to the near node. That means it was earlier pointing, rear was earlier pointing to 10. Now rear next points to 20. Rear is basically a pointer variable. Now it points to 20. And rear becomes the current node only. Now rear points to this 20th node only. Okay. Now let us push another node. That is what you can say, insert 30. Now again the same process repeats. Now earlier rear was pointing to 20. Now the new node happens that rear was earlier pointing to 20. Now rear next, that means which was pointing to 20, will point to the next node, that is new node, and rear becomes the new node becomes the new rear node. Rear is basically a pointer. So let us delete or dequeue the item, so it ends from front. So basically what happens? So we take a pointer to point to the front, that is temp equal to front, and we change the pointer variable, that is front equal to front next. So now front, which was earlier pointing to 10, now it points to 20. So it is not null and rear is not null, so there is nothing to so it is not empty or something like that. So now we free the first node, that is temp, which was earlier pointing to the front element, that was 10, now it is deleted using or it is written to the memory, hit memory, that is free 10, using free 10. So this is another data structure, that is doubly linked list. Doubly linked list, in here we have what we have dealt earlier in linear linked list, that there is only one address element which points to the next address element, next node. But in a doubly linked list, there are two links. The first points to the previous node and the second points to the next node in the list. So in a that is the data structure of this is defined by the struct node, that is in data. And struct node star next is the points to the next node, and struct node star previous points to the previous node. That's how a doubly linked list works. So the linear linked list earlier, what you have seen, it has only one pointer address that points to the next node. In here there are two, next and previous. Next point to the next pointer points to the next node in the linked list, and previous points to the previous node in the linked list. Such as B, if you take B, B's next points to C, but B's previous points to A. Same thing for A. But A is the first term, so A previous is null, A's next is actually B. Same thing which happens with B, which is the last element, B points to null, but B's previous points to C. So this is the last item of the linked list we are going to study, that is about the circular linked list. Circular linked list, we have seen that the null pointer is unused. So we can use that null pointer to point to the first element of the list. So we go to the first definition first, that a circular linked list is a sequence of elements in which every element has a link to its next element in the sequence, and the last element has a link to the first element. So the last element's link, which was earlier pointed to null, it now points to the first element of the linked list. This means that the circular linked list is similar to the single linked list, except that the last node points to the first node. So we now come to the end of the linked list data structure. Now in our next class we will study about trees.